Hi, so this is topic D.4, and the essential idea here is that excess stomach acidity is a common problem, and this can be alleviated by compounds that increase the stomach pH by either neutralizing the stomach acid or by reducing the secretion of stomach acid. So in the stomach, you have digestive fluid which contain gastric juices, including hydrochloric acid. So this is the stomach acid. The gastric juice also has enzymes, pepsin, has water and salts. And the acid concentration is between this range. So based on this range, we can find the pH of the stomach. At any point, if you think you need to go back on topic 8 to review calculations, please do so. The pH is minus log of H plus, so you can find the pH for these two concentrations. So this is the pH range of the stomach. Now, the functions of the HCl in the stomach is to denature proteins and provide optimal pH for digestive enzymes. So you have the enzymes pepsin here. So the HCl provides the optimum pH, and it also kills harmful organisms present in the ingested food. Now, excess stomach acid will cause health effects such as indigestion, gastritis, heartburn, and stomach ulcers. You have to remember these issues. And antacids, they will work by neutralizing any excess HCl in the stomach. And during this reaction, the pH of the gastric juice is going to increase. So it makes the gastric juice less acidic by increasing the pH. Now, these are examples of antacids: calcium hydroxide, magnesium hydroxide, aluminium hydroxide. You can remember these three hydroxide by a little acronym MAC: magnesium, aluminium, and calcium hydroxide. There's also sodium carbonate and sodium bicarbonate. So all these are weak bases. Now, we will not be able to use strong bases such as sodium hydroxide and potassium hydroxide. These are strong bases and they are harmful to the body. They would be very effective to neutralize the acid, but unfortunately, we cannot consume it. Now, if sodium bicarbonate is consumed, let's see what's the reactions that takes place. So sodium bicarbonate. Now, this is going to produce ions. So it's going to ionize in the stomach. And the hydrogen carbonate ions will then react with the excess acidity in the stomach and is going to produce carbonic acid, which is unstable and which will form water and carbon dioxide. So the carbon dioxide is going to form bubbles and is going to result in belching. Now, if there is any excess antacid in the stomach, so we have the Na plus and we have any excess hydrogen carbonate, this is going to combine again, Na plus and HCO3 minus, this is going to combine again, and these are going to be absorbed by the body. So if we have, for example, calcium carbonate, this is going to form Ca2 plus and CO3 2 minus. Now the CO3 2 minus is going to react with H plus, so 2H plus, and is going to form carbonic acid again, which is also going to give you water and carbon dioxide, resulting in the belching. If you use another antacid, magnesium hydroxide, this is going to give you magnesium and hydroxide ions. And the OH minus ions is going to react with H plus, excess acidity, to give you water. And if you have aluminium hydroxide, so the same thing, you're going to get aluminium ions and OH minus ions. So 3 here, sorry, there should be a 2 here. So then you have OH minus ions, which will react with H plus to give H2O. So again, you have this neutralization reaction. Now, when you're taking these antacids, we see that there is the formation of the positive ion, the cation which is produced, which means that these cations will linger in the body, and these cations can produce side effects. So, for example, aluminium can cause constipation. And if you have antacids that have both aluminium and magnesium, some antacids are a combination of aluminium hydroxide and magnesium hydroxide, these also produce undesirable constipation or diarrhea. So these are side effects. Moreover, magnesium is a laxative, which means that it can produce diarrhea. And it is generally used prior to endoscopy, where we need to clean the column. So then magnesium hydroxide is given for its laxative effect. These are other side effects of antacids. For example, aluminium hydroxide reduces concentration of phosphates in body fluids. Carbonates and hydrogen carbonates produce carbon dioxide, which can cause bloating and belching. And if you consume antacids in excess, it can affect the electrolyte balance in the body, leading to diarrhea, constipation, heart failure, or kidney stones. Now, some antacids will contain alginates. Alginates will produce a layer which prevents the stomach content from moving up into the esophagus. So there's a physical barrier on the stomach content. So the alginates form that layer, that foam, that physically prevent any stomach content from rising into the esophagus and prevents heartburn and acid reflux. Another substance which is also found in some antacid is dimethicone. Dimethicone is an anti-foaming agent. Remember when we said that carbonates and hydrogen carbonates produce carbon dioxide, which cause bloating and belching. So dimethicone is going to relieve that bloating, flatulence, and abdominal pain, which is caused due to excessive gas in the digestive tract. So it allows bubbles of carbon dioxide to come together and leave the body through belching. So then it doesn't cause that bloating in the body.